Vanakkam. Welcome to this course on classics and neuroscience. In this series of videos, we are looking at classic Nobel Prize winning works in neuroscience. In this series, in particular, we are looking at the classic Nobel Prize winning work of Santiago Ramon y Cajal. In this video, we will focus our attention on the circumstances that led Santiago Ramon y Cajal to turn his attention and focus to the nervous system, and how the giant, the behemoth that woke up in 1887, 88 or 89 never slept until his death, practically working several nights and days, working at home, working in the lab, working everywhere. So, once that giant woke up, the history of neuroscience changed forever. How did that happen? What was the metamorphosis? We see those things in this class. So, before 1887, Cajal had studied practically every type of cell in the human body except the nervous cell. He had studied dental cells, crystalline cells, corneal cells, epithelial cells, blood, adipose cells, conjunctive cells, bones, cartilage, muscles. Practically every cell type that was there to be studied was already studied by Cajal before 1887. So, in 1887 he decided to turn his attention to nerve cell, but why? We will see why. The first to study the nervous system properly under the microscope was not Cajal, but was rather Christian Ehrenberg, who described the nervous system or the nervous cells as ganglionic corpuscles and projections, branching fibers that he described. Ehrenberg assumed that the structure of the nervous system was similar to the vascular system, which was essentially an interconnected network of arteries, veins, capillaries. This is what you have in the vascular system. You have a similar system in the nervous system, a similar network in the nervous system, except that it is performing a different function. This was the hypothesis that practically dominated the entire 19th century neuroscience. This is what Ehrenberg also assumed. Meanwhile, Joseph von Gerlach also observed a network which he called as a reticulum, an intricate network, which is a fine net, is what he observed. And Otto Karl Friedrich von Dieters practically came up with a revolutionary method to study nervous system, which he called as the microdissection technique, using a material called as osmium tetroxide. And what he found was tapered and branched out repeatedly, that he called as protoplasmic prolongations, which is now called as dendrites, and he described axis cylinders that did not taper and practically maintained the same diameter throughout. These he called as axons. So, those that did not change diameter are called axis cylinders or axons. They were later called as axons. Those that tapered and branched out repeatedly and went on tapering until it almost disappeared, those were called as protoplasmic prolongations, or now they are called as dendrites. Critically, von Dieters did not observe anastomosis, that is, connections between these type of different fibers or the same type of fibers connecting with each other, was something that von Dieters did not observe. But despite this observation, the dogma that the system essentially was a reticulum, was a network, persisted. This dogma continued to persist. This was about 20 years before the birth of Cajal, if I recall correctly. Please check this. I think this was before 20 years before the birth of Cajal, or about 19 years before the birth of Cajal. So, for nearly 50 years and counting, this dogma persisted. So, such was a strong belief that people had in this dogma that no one bothered to question this. Although the observations that von Deuters had were different from this hypothesis, but he somehow did not speak up about that. He himself did not find anastomosis or connections, and these anastomoses are what are required to establish the presence of the reticulum or the network, but anastomoses were not found in practice or in reality. Swiss scientist Albert von Kolliker, about whom we spoke earlier, he declared in 1850 that the nervous system is the only unknowable structure of the body. In the 1880s, Cajal was using carmine and hematoxylin to study the cells of the nervous system or the neurons, and when he did that, only the neuronal cell bodies were stained, but the fibers, both the axons and the dendrites, were not stained. Cajal learned about the Golgi method to stain neurons from his colleague Louis Simaro in Jan 1887. This was a critical turning point. So, this chance meeting with Louis Simaro completely turned the career of both Louis Simaro in some sense and definitely Santiago Ramon y Cajal. But then by the time this Golgi method was considered very unreliable, whimsical, capricious, lot of uncertainty regarding the outcome. It sometimes produced stunning results, but sometimes produced practically nothing. So, people did not know what should be done to have stunning results and what should be done to avoid nothing results. This was something that nobody knew. So, when Cajal started working with this method, that is the Golgi staining method in 1887, the rest of the histology community by that time had already abandoned this technique. But then Cajal was this rigorous experimentalist, and he believed that it is possible to optimize the experimental approach so that he will get the best possible outcomes. This is the experimentalist's belief, that you must control the things that you can control, and the results will then show up because you have practically controlled everything that you can control. So, Cajal went out to optimize the relationship between the only two reagents in that reaction. One was potassium dichromate and the other was silver nitrate, and he optimized concentrations, the amount or volume, and for how long they were bathed in these solutions, or the duration of the chemical baths. Cajal was absolutely convinced that the task of refining the stain and improving the results would require great patience. In that sense, it was more of an art. Recall that Cajal was someone who wanted to be an artist. Cajal was this artist who went on to become a scientist. Recall that. So, his patience really was one of the primary reasons why he succeeded in optimizing the Golgi techniques to such an extent that nobody else, including in some sense Golgi himself, could not optimize it to this level. such was the precision and refinement with which Cajal worked. He worked on this for several months, 6 to 8 months before he could get reproducible results. This is absolutely critical in experimental science. Your experimental results must be reproducible, must be replicable by you first. Of course, you must be able to replicate your own results, but if you are describing the method and the approach you took, others must also be able to replicate this method. That must be the rigor with which you perform the experiment, you control the experiment, and you describe the experiment, all of this. So, Cajal said that ideas do not show themselves productive with those who suggest them or apply them for the first time. Rather, ideas show themselves to be productive only with those persevering workers who feel them strongly and put all their faith and love in their efficacy. They need to completely observe themselves, they need to be completely invested in this process. These are individuals who put all their faith and love in the efficacy of these ideas, who must feel these ideas very strongly, who must strongly believe in those ideas. Only then these ideas will show themselves or will manifest themselves. Very critical statements coming from a brilliant scientist. Important to note are his patience as an experimentalist. When your experiments fail, that means you have discovered one method in which you should not do the experiment, and then you refine that and you continue. This was Cajal for you. He was this rigorous experimentalist who took 6 to 9 months to properly refine that. Slide after slide, sample after sample, every slide that he prepared produced stunning results because he knew exactly what to do. So, Simaro even said that the Golgi technique suggests, it does not demonstrate. This is Louis Simaro who introduced the Golgi technique to Cajal, but for Cajal results were real. Simaro appears to suggest that Golgi technique suggests but not demonstrate, means that these results are imaginary or illusory or otherwise not true. But what Cajal saw with his own eyes were that the results were real. So, from 1888, Cajal decided that he will dedicate his time only to the study of the nervous system and stop all other research. He will perform only the study of nervous system, and he decided to tackle the following questions. How are the elements in the nervous system related? What are the nature of these relationships? Are there anastomoses between fibers or not? Anastomosis means connections between fibers of the same kind and different kind or not. Physical connections. Anastomosis means physical connections. Do the fibers form a single continuous network or reticulum or not? So, he was so absorbed in his work that he would say, or once he famously said that I have 4 children and my 5th is my microscope. This was a famous statement that he apparently made, except when he made this statement, Cajal actually had 5 children. So, he was absorbed so much perhaps that he forgot how many children he had, or maybe likely this is a misquote by somebody. It is not clear which is true, but that is not important. What is important is that he considered his microscope as one of his children. That is important. Based on all these situations, Cajal decided to turn his attention entirely to neuroscience, and these were the circumstances that led him to focus entirely on the nervous system. And when he woke up, when he started doing these studies, no one could stop him. With this, we come to the end of this video. Thank you for your attention.